case you're still wondering what all this fuss is about DeepSeek-R1 and how its model architecture can be a long-term competitor to large concept models that I covered in my previous video, keep watching. Unless you've been living under a rock or something, you must have heard about DeepSeek recently. The company's R1 model is a large language model that has caused quite a stir in the AI industry, and not just because it crashed the stock market. While the political and financial sides of its impacts are fascinating, I think they often overshadow the innovative and methodological aspects of the build itself. Am I the only one who thinks reinforcement learning is making a comeback? After many successful pre-trained models that heavily relied on supervised and semi-supervised methods, DeepSeek R10 was trained only based on large-scale reinforcement learning, which is really impressive even with its issues with readability, as they admit. Their updated model, DeepSeek-R1, uses cold start data before reinforcement learning with performance comparable to or even surpassing OpenAI O1. The crazy part is that this all took less than $10 million, which is ginormously less than the $500 million budget that OpenAI spent on developing its O1 model, let alone the hundreds of billions of dollars that the US AI industry has spent and is spending to build the state-of-the-art generative models. Here's how DeepSeek developers phrased it. We explored the potential of LLMs to develop reasoning capabilities without any supervised data, focusing on their self-evolution through a pure reinforcement learning process. And all for a good reason, to minimize the time, budget, and computing power needed for massive data training. After claiming that most recent LLMs are getting us closer to AGI, he admitted that in the context of reasoning capabilities, OpenAI's O1 series were the first to introduce inference time scaling by increasing the length of the chain of thought reasoning process, which resulted in significant improvements in reasoning tasks such as mathematics, coding, and scientific reasoning. So essentially, the chain of thought reasoning process used in this new DeepSeek model series explicitly instructs the model to generate step-by-step clarification of its reasoning process before giving the user the final response. The R1 model's developers believe the main challenge is effective test time scaling, and a solution they thought of was the use of reinforcement learning. If you're new to this, think of reinforcement learning as a type of continuous trial error in a game of reward and penalty system, with feedback on how well a system works and using the feedback to improve itself. In simple terms, the machine takes an action, like playing a game, and gets feedback, either a reward or a penalty based on how well it does. This process repeats until it learns the optimal behavior. So the AI isn't told how to win. Instead, it learns through trial and error. If it wins, it is reinforced. If it loses, it is ignored. But here's the cool part. Reinforcement learning can handle delays. Sometimes doing the supposed correct move now means you have to take a hit later. Even more interesting than that is model-free algorithms, which adapt quickly to continuously changing environments and find new strategies to optimize results. These mechanisms help RL algorithms outperform humans in taking the correct path and coming up with good decisions. As you guessed, this type of system requires less training data and human interaction. In traditional machine learning algorithms with supervised learning methods, humans are needed to label data to feed to the algorithm as a base of information, while a reinforcement learning system learns by itself and offers mechanisms to integrate human feedback, allowing for systems that adapt to human preferences and the environment. Reinforcement learning mainly focuses on maximizing long-term reward, which makes it suitable for real-world scenarios where actions have prolonged consequences or in situations where feedback isn't immediately available for every step, since the RL algorithm learns from delayed rewards. Reinforcement learning is based on the Markov decision process, which is a mathematical modeling of decision-making that uses discrete time steps. At every step, the agent takes a new action that results in a new environment state. This way, the current state is based on the sequence of previous actions. What's more interesting is the exploration-exploitation trade-off in RL systems. So here's how it works. While the agent is moving through the environment based on trial and error, it builds a set of if-then rules to decide the best course of action to achieve maximum reward. But at this point, it has to decide whether it chooses a known reward in the current state, which is called exploitation, or delays the reward in anticipating a better one further down the line to learn new state action rewards, or exploration. Now, back to the DeepSeek paper. In the base DeepSeek model, reinforcement learning was directly applied, which, as they mentioned in their paper, allows the model to explore chain of thought for solving complex problems, resulting in the development of DeepSeek-R1 with capabilities such as self-verification, reflection, and generating long chain of thoughts. In order to save the training costs of RL, they adopted the group Relative Policy Optimisation method, which ignores the critic model and only estimates the baseline from the group scores. They used a rule-based reward system with two types of accuracy and format rewards. They also used a training template to guide the model's behavior, as you see here. This whole process makes DeepSeek-R1 the first open source model that shows LLMs can achieve reasoning capabilities purely based on reinforcement learning and without relying on supervised fine-tuning. As you can see in this table of comparison, the DeepSeek-R1 with only reinforcement learning produces comparable results or even better results than the two versions of OpenAI O1 models on reasoning tasks. What's even more fascinating is that this R10 version has the capability of improving its own reasoning capabilities autonomously in what they call self-evolution. It naturally acquires the ability to solve increasingly complex reasoning tasks by leveraging extended test-time computation, which helps the model to explore and refine its thought processes and even achieves behaviors such as reflection, where the model revisits and reevaluates its own previous steps and exploration of alternative approaches to problem solving arise spontaneously. They call this fascinating behavior of R10 the aha moment, as you can see in this example. So instead of explicitly teaching the model how to solve a problem, they simply provided it with the right incentives, and the model autonomously developed advanced problem-solving strategies, which goes to show the potential of reinforcement learning for solving complex reasoning problems. However, they soon found out that the R10 model has some issues with readability and language mixing. So they tried a pinch of supervised fine-tuning the data to enhance its performance. That resulted in the DeepSeek-R1 model, which applies reinforcement learning starting from a checkpoint fine-tuned with thousands of long chain of thought examples. This DeepSeek-R1 model has been the result of two questions in the research journey. 1. Can reasoning performance be further improved by incorporating small amount of high-quality data as a cold start? And 2. How can we train a user-friendly model that not only produces clear and coherent chains of thought, but also demonstrates strong general capabilities? To fine-tune this enhanced model with the chain of thought data, they have explored several approaches, including using few-shot prompting with a long chain of thought as an example, directly prompting models to generate detailed answers with reflection and verification, and even gathering DeepSeek-R10 outputs and refining the results through post-processing by human annotators. After fine-tuning with the chain of thought data examples, they applied the same large-scale reinforcement learning training process as employed in the DeepSeek-R10. Because of language mixing issues with the R10 model, this time they came up with a solution, and that was to introduce a language consistency reward during the reinforcement learning training, which made the R1 model's responses very readable. Clever, huh? Once this readability issue was solved, the future fine-tuning of data helped the model with writing, role-playing, and other general-purpose tasks. But they didn't stop there. They even implemented a second round of reinforcement learning to improve the model's helpfulness and harmlessness. I'm sure StatQuest would have called it double bound. But here's the controversial part. The distilled versions of the DeepSeek models using other open source models such as Llama and Qwen. I say controversial mainly because some Silicon Valley giants such as OpenAI accuse DeepSeek folks of cheating with AI distillation, which also comes with its own legal issues about intellectual property and market competition. But since this channel is more focused on the technical side, here's a simple explanation of the distillation process. AI distillation is a process of embedding the knowledge of an existing LLM or any other large generative model into a smaller and less expensive model. With this method, we can achieve efficiency by minimizing the resources needed for developing state-of-the-art models and effectively bypassing making a model from scratch. DeepSeek showed how the reasoning patterns of larger models can be distilled into smaller models, which results in better performance compared to the reasoning patterns discovered through reinforcement learning on smaller models. This way, they managed to produce models such as the DeepSeek-R1 distilled Quen series of models, which show exceptional results on benchmarks such as Math 500 and LiveCodeBench. As you can see, the main DeepSeek-R1 model also surpasses many state-of-the-art commercial models on many tasks such as common sense and reasoning, question answering, code, and summarization. I'm going to end this video with DeepSeek's own conclusion about the performance of the original versus distilled models. We can draw two conclusions. First, distilling more powerful models into smaller ones yields excellent results, whereas smaller models relying on the large-scale RL mentioned in this paper require enormous computational power and may not even achieve the performance of distillation. Second, while distillation strategies are both economical and effective, advancing beyond the boundaries of intelligence may still require more powerful base models and large-scale reinforcement learning. I'm really curious to know what you think about the future direction of generative AI and the potential competition of reinforcement learning-based LLMs such as DeepSeek versus the large concept models or LCMs that I explained in this video.